Assalamu alaikum. Bismillahirrahmanirrahim. My name is Engineer Dr. Fawaz Salam Khan, and today my topic of discussion for the webinar is Biomedical IoT, Enabling Technologies, Design and Future Direction. So I'm going to just give me some brief introduction of myself. Basically, I'm a postdoctoral research fellow on Global Talent France visa at University of Lille, France, under CNRS France funding. I have earlier completed PhD in electrical engineering with a specialization in artificial intelligence from UTHM Malaysia with FRGS funding. Following a BS in computer engineering from Sir Syed University of Engineering and Technology back in 2003, and then computer engineering from NED University of Engineering and Technology back in 2011, then following with the computer science MS from International Islamic University in 2020. So basically, uh, I have more than 2 decades of experience in which about an decade experience in academia, where I have done various high impact projects as principal investigator and get funding from renowned institution, not only in Pakistan but also from Silicon Valley and the UK. So I've also attended multiple conferences and published various articles in impact factor journals and Scopus journals and conferences. I have also managed to complete different projects from US, Malaysia, France, and the UK. And the area of expertise is medical imaging, laser-induced breakthrough spectroscopy, machine learning, deep reinforcement learning, and UAV technology. So this is the basic introduction of myself. So let's dive into the content of today's webinar. I'm going to discuss with the introduction, then give thought about the IoT in healthcare, benefits of IoT in the healthcare, role of the biomedical engineering, uh, its working basically. I will discuss some of the case studies and give the live demonstration of few projects which have been done in top universities in Pakistan. Then we'll discuss with the IoT system architecture, communication technologies, common IoT protocols, edge and cloud computing. Then go for the challenges about what will be the most important for this biomedical IoT related issues. So let's start with the basic introduction. Normally, if you are talking about the IoT, first I'm going to give the brief understanding about what IoT is. So if we are talking in terms of the biomedical IoT, it's like a biomedical sensors, communication, network, plus edge, cloud and edge analytics and healthcare applications. Similarly, if you are talking about the basic definition, so they basically IoT refers to the network of physical devices connected to internet that collects and share data. So there can be various components available for doing all these things. Like for example, if you are talking about the sensors and devices, these are used to collect data from different environments such as temperature, pressure, motion, heart rate, or humidity. Example, temperature sensors in a smart thermostat. There can be other components like, for example, you may need some kind of a network connections to communicate the medium with the devices to the internet. Like, for example, if you're talking about the healthcare system, IoT may improve and diagnose monitoring and patient care. So, if you see in the figure, you can have normally a signal which will be taken from any human being, like from heart. The signal goes to some devices, and then it will be converted into the data transmission in the form of some web or in some cloud or anything like where we store the data. So normally at the if you are talking about the edge computing in terms of this signal processing. The raw data from sensors is processed locally edge in the cloud or in the cloud make it more meaningful for understanding. So, cloud computing or data storage stores a huge volumes of IoT data. For example, if you are talking about the applications or the users, there can be some final layers which you see in the figure, that the data transmission are more towards on the final layers with the application, with some kind of a user interface, where we can visualize or interact with the signal which will be received from the human. So if you're talking about more towards on the IoT as in healthcare, so there can be various things we need to understand. Like for example, if you're talking about IoT in healthcare, involves connecting devices like wearable and sensors, collecting and sharing real-time health data. This enables remote patient monitoring, personalized treatments, better assist and tracking, and proactive intervention, enhancing care quality and efficiency. For example, if you are talking about, if you see the figure, there can be various interactions between a remote monitoring, which will be using which will be used for the connections of wearable devices. Similarly, to collect this can be used to collect the data with the vital health statistics from the remote the patient remotely. Then we will have a smart hospital system where we used IoT, AI, and automations to link medical devices, systems, and administrative processes. Similarly, if you're talking about a telemedicine in terms of a mobile health, IoT devices enables remote monitoring and virtual medical consultations as well. So there can be multiple benefits. We will discuss either why this medical or biomedical IoT is more important these days for engineers, and specifically if we are talking about the people who are pursuing their care and who wants to pursue their career in biomedical engineering related fields, that can be more beneficial. So, what are the major benefits if you're talking about? For example, I'm talking about the basic thing related to a biomedical IoT, which brings together medical sensors, wireless communication, and intelligence data analytics to improve the quality, accessibility, and efficiency of healthcare service. For example, there can be number one can be, you can say, continuous patient monitoring. Patients can be monitored 24 by 7 using wearable implantable IoT sensors. Example, ECG patches is pulse oximeters, glucose monitors. Doctors can be receive real-time data on vital signals and respond immediately to the abnormal conditions. So, for example, we can say a smart ECG patch sends different kinds of alerts to the cardiologist at mobile app. So early disease detection and preventions can be the second point. The IoT sensors collect continuous health data, allowing AI systems to detect early signs of diseases like diabetes, heart attacks, and there can be sleep disorders as well. So we can also have if you're talking about more towards on the predictive analytics sides, it can also be triggers alerts before the medical emergency occurs. So a continuous glucose monitoring, just giving an example of this, if you continuous glucose monitoring helps detect insulin resistance early. Remote healthcare and telemedicine can be another option. So there can be reduced minimum hospital visits. IOMT enables remote monitoring and time cares, reducing the needs of the frequent hospital visits. So uh, there can be further more benefits of getting all these biomedical IoTs. Like for example, if we are talking about a remote healthcare and telemedicine systems, so enables remote patient care without needing hospital visits, benefiting the elderly or rural populations with limited access to the hospital. Examples like patients have vital data is sent from home to doctors via cloud-based dashboards, or you can say an IoT device can adjust dosages or therapies based on real-time psychological or physical based systems. So there can be multiple responses as well at that time, and that can promote precision medicine where treatment is tailored to individual health profiles. We can give some examples like for example, smart insulin pumps are available these days automatically, which are used to automatically inject the right insulin dose, and then can have improved hospital management system. So we have different kind of things. For example, if we are talking about data-driven diagnostics, so IoT devices collect real-time data, as I told earlier, and have early detection of health issues. So reduces hospital operational cost as well for these type of sensors, where we are having smart asset tracking systems, or you can say there can be integration with different kind of AI and a smart diagnosis system. For example, like AI module analyzes biomedical IoTs these days to detect diseases with high accuracy, that can enable real-time diagnostic support for clinics. And if you're talking about, for example, an AI-driven ECG classification system using IoT collected heart signals. So there can be also have some other things like data-driven research and health insights are available for the biomedical IoT engineers, which have a continuous data collection, provides large data sets for medical research. So normally these days in Pakistan, like in different hospitals, you can get a big large data sets from different hospitals available with different diseases, and all these data can be collected by using biomedical IoT devices as well. So continuous data collection provides large data sets for medical research, which helps to discover new health patterns, disease correlations, and treatment outcomes, which can be very beneficial for that. And having this, I'm saying that this also may reduce the cost of the preventive care, or through IoT reduces hospital admission and readmission system runs, because if you design some kind of a device and it will be used frequently, so it will get different kind of data on high priority basis. So remote monitoring minimize travel and resource costs for both patients and hospital. So once all these things enhance the elderly and chronic care, can also biomedical IoTs suppose independent living for seniors by monitoring mobility and modification of adherence and fall detection as well. So there can be also some kind of global health and pandemic responsibles, because IoT systems can be track and monitor disease outbreaks, which can immediately get some early detection system as well. So if you are talking about the role of biomedical engineer in IoT, there can be various things like if you're talking about design and integration of biosensors, this can be data acquisition and signal processing and ensuring safety and regulatory compliances. So development and maintenance of IoT-based system as well. So now I am going to give one kind of an example, which is completed at APSIM. A project was done at Air University, Islamabad, and they have their I'll give you a brief look on this. So as you see, this is the device which was made by some of the engineers at Air University Islamabad. So I'll give you the brief working of this device, how this work, and how many layers are available to process all these things. So this is the general idea, which biomedical engineer can easily develop some kind of biomedical IoT sensors for getting all the informations, not only at the uh, educational or academic side, but can also make some piece development for the hospitals as well. So I'm going through with the working. For example, if you're talking about the sensing layer. Normally, a biomedical device, IoT device, can be designed with some kind of layers are implemented. So sensor layer can also be said as a perception layer. So this is the data acquisition layer where sensors and biomedical devices to collect psychological or environmental data directly from patient or surroundings. For example, if you see, as you see in the earlier figure, there can be variable ECG sensors monitoring heart rhythms. There can be smart temperature sensors, measure body temperature, glucose monitoring sensors, detect blood sugar levels, oxygen saturation sensors, SpO2 measures oxygen level in the blood, and environmental sensors we can use for the monitor room air quality for asthma patients as well. So there can be various case studies available. Like, for example, a wearable ECG patch senses the patient's heart electrical signals in real time, so a signal as you see in the video earlier, and records any abnormal rhythm there can be from the patient. So second is the network layer, which is used basically, or it's a communication layer. It's a communication layer, so they can transfer the collected data securely from sensors to the gateways, like for example, smartphones or cloud servers using wireless communication technologies. So wireless technology can be short range technologies or long range technologies. If you're talking about the short range, we can have Bluetooth or Zigbee or Wi-Fi, or the large range, you can say 4G, 5G, NB, IoT or LoRaWAN. Gateways can also be used for mobile apps or routers acting as an intermediate devices. So there can be various examples in this case. The ECG patch transmits the heart rate to the mobile app via Bluetooth, and then link the send to the cloud or the Wi-Fi. So the next layer is the processing layer. So processing layer is the most important layer, which is the middleware or the cloud layer, you can also say. So the function of this layer performs data storage, filtering, processing, and analysis either on the edge or local or a cloud remote site. So if you're talking about this side with it also applies AI and machine learning and algorithms to drive meaningful insight. Like for example, the typical task can be noise removal or feature extraction from the sensor data, predictive analytics, for example, disease detection or anomaly detection. This can secure data storage and access management as well. So uh, multiple layers are involved in this scenario. Like, for example, if you're talking about some kind of cases, like case study, the cloud server applies on deep learning algorithm to the ECG data to detect signs to any kind of predictions or disease. Can be like for there can be to compute different level of accuracy and risk levels. So next layer is the application layer. Application layer is where the process data is presented to the end user, doctors, patients, or hospital in the form of dashboards, alerts, and recommendation system. For example, mobile health apps can be display the like heart rate or glucose levels, or dashboards with patient risk predictions, automatic risks alerts and for the emergency conditions like irregular heartbeats detected or anything like that. So if the system can detect an abnormal pattern, it sends to the real-time alerts to the doctor's dashboard, and a notification to the patient's smartphone advising immediate medical attention. So these layers are very, very important to design the any kind of a biomedical IoT system. So IoT system architecture is consists of very interesting. It is a multi-layered system that enables a real health monitoring and intelligent healthcare delivery. It begins with the perception layer, you can say sensing, where biomedical sensors and wearable devices collect psychological data or physical data such as heart rate, ECG, glucose levels, or oxygen saturation, as well as an environmental parameters like temperature or air quality. This data is then transmitted through a network layer using wireless technologies such as Bluetooth, Wi-Fi, or any gateways. Once the data is reaches to the processing layer, It is stored to filter and analyze the edge computing or cloud computing as seen in the figure. Like, for example, the perception layer is connected with the network layer and the processing layer, then it will be goes to the application layer. So finally, the processing layer is stored and filtered and analyzed using edge computing data, as I told earlier. And lastly, the application layers delivers these processed insight to the end user, including patients, doctors, or healthcare providers, via dashboards, mobile apps, or alert systems. Enable timely decisions can be made at that time by personalizing treatments and remote healthcare system. So together, these layers form an integrated ecosystems with sensing and communication, processing, and multiple, you can say, application work seamlessly to enhance healthcare outcomes, which can improve the patient safety and reduce operational costs. So, if you are talking about the communication technologies, IoT systems are the backbone for the Internet of Things, which enables seamlessly data transfer between devices, gateways, and cloud technologies in the made of the system. Like, for example, if we are talking about any kind of Sigfox or LoRaWAN or cellular network, allows the devices to transmit data over great distance, suitable for remote and healthcare monitoring system, which have an IoT-based system like data rate, range, power consumption, or network scalability, ensuring that IoT devices are reliably communicate while enhancing or balancing energy efficiency and performances for these systems. Together, these communication technologies form a robust network infrastructure that enables real-time monitoring systems, analytics, and intelligent decision making for IoT systems. So, there can be common IoT protocols which we have, like which are standardized rules that enables devices to communicate efficiently, reliably, and securely within an IoT-based systems. Commonly, IoT protocols include MQTT, which is message queuing, telemetry transport, COAP. There can be another protocol, HTTPS, and different protocols, data distributed services, DDS. MQTT is lightweight, normally published, or you can say subscribe protocol, designed for low bandwidth, low power devices, commonly used for healthcare and wearable systems. So if you're talking about different protocols like COAP, it's an optimized version for constrained devices and network enabling IoT sensors to sense request data efficiently. So HTTPS and HTTP allows IoT devices to communicate over web using standard client, you can say, server request, and have these protocols work by defining how messages are transmitted and transported and received, ensuring interoperability between the heterogeneous devices, secure data transfer, and timely delivery of information in the IoT-based network. So overall, if you are asking about or saying that COAP or a constrained application protocol, which is normally designed for constrained devices and low power network. So these devices like IoT sensors can request data from different kind of devices which are interconnected with the server and have the request from HTTP, then proxy and COAP servers. So in the next discussion, you can say that what we have a differentiation between an edge and a cloud computing. So edge computing processing happens near the data secure. So edge computing and cloud computing are the two approaches to processing the IoT data. So each in cloud computing, data processed locally on the devices or nearby gateway, reducing latency and bandwidth usage, which is ideal for real-time applications like wearable ECGs you are talking about. So wearable ECGs can monitor or insulin pumps sometimes, like, or cloud computing on the other hand process stores data on remote servers, offering virtually ultimated storage and powerful analytics, which can be a suitable path for long-term health data analysis. So AI model training and large-scale IoT development, while while if you say that edge computing provides faster responses time and lower dependency, whereas cloud computing provides scalability, centralized management, and advanced computational resources. So, in many biomedical IoT devices systems, and hybrid approach can also be used, where immediate decision makings are made at the edge, and aggregated data is sent to the cloud for deeper analysis and storage. So if you see in the figure, all these things are interconnected, like edge computing with the cloud computing, centralized data processing analytics. Then can be have an you can say an hybrid system used for edge that handles real-time tasks, for cloud manages long-term analysis. So another way, like for example, if you're talking about some of the example in terms of an hardware or an edge devices. So in I'll give an example here. For example, in an hospital system, the intensive care unit, ICU, patient safety is more, you can say, important or paramount, and timely intervention is critical at that time. So to enhance cardiac care, the hospital implemented an edge computing solutions for real-time ECG monitoring. So for example, where wearable ECG sensors were deployed on patient for to continuously record heart activity. These sensors transmitted data wirelessly to the edge computing devices, local at the you can say bedside, minimizing latency and ensuring immediate processing. So the edge devices analyze the ECG data locally using machine learning algorithm to detect other abnormalities. So when irregularities were identified, the system instantly give alerted healthcare providers via mobile devices, enabling enabling rapid response and intervention. So this localized processing and reduce dependency on cloud services as well. So as you see in the figure, there can be edge devices where we use Jackson Nano or Jackson Xavier, that can also be used with some kind of a localized connectivity, and these localized processing reduce the dependency on cloud services, so which decrease the data transmission and elevated bandwidth constraint. So by you can say by integrating edge computing into the ICU monitoring system, the hospital improved its availability to provide timely and effectively healthcare system, which demonstrate the transform the patient's potential of edge computing to enhance the outcomes of this system. So if you see all these have a connection with some kind of an edge and cloud computing. So normally, these are the challenges which we face. So IoT systems, while transformative, face a variety of challenges must be addressed for effective deployment. One of the foremost constraints is security and privacy, as IoT devices collect and transmit large volumes of sensitive personal and organizational data, making more vulnerable to the cyber attacks and unauthorized access. So you can say interoperability is another significant challenge, because IoT ecosystems often consist of heterogeneous devices. So these heterogeneous devices have different kind of protocols and standards which can impede seamlessly communicate and integration. So power management system can be another point for this challenge. Like it can have very critical sometimes, for especially for wearable implantable devices, remote desktops, or remote devices then have some kind of rely on the batteries, which can be requiring innovative solution, prolong operational life. So data management and scalability can pose challenges, as an IoT systems generalize massive amounts of real-time systems that must be processed and stored to analyze. So additionally, there can be network reliability issues as well, where can be produced by some kind of a latency, which will be like some kind of real-time systems like healthcare monitoring or industrial automations, where delays can have serious consequences. Other challenges include cost of development and maintenance, lack of standardization, you can say, regulatory and compliance issues, which can hinder widespread of adoption and interoperability. So addressing these challenges is essential to unlock the full potential of IoT-enabled system, and while ensuring security, efficiency, and reliability. So there can be some kind of a regulatory compliances like FDA, CA, ISO standards. There can be multiple things as well. So I hope you will get a brief knowledge about the biomedical IoT systems. So that's all from my side. Thank you very much.